Good morning. In this class, we are studying the reactions of alcohols. Reactions of alcohols. Reactions of alcohols. First, we are discussing about reactions involving the cleavage of OH bond. Cleavage of OH bond. That means if you take alcohol, ROH, this bond will break. OH bond is breaking, and that type of reaction. First, we are discussing reactions involving the cleavage of OH bond. Okay. Example. First one. Number one. Acidity of alcohol. Acidity of alcohols. Acidity of alcohols. This we can explain. The acidity of alcohols is coming under the reactions involving the cleavage of OH bond, and we know that alcohol means ROH. Now in this class of reaction, which bond is breaking? The OH bond is breaking, and the reaction is the alcohol is undergoing reactions. Okay, first one is acidity of alcohol. Look at we can explain the acidity of alcohols. Acidity of alcohols. First, you must remember that alcohols are weakly acidic in nature. Alcohols are weakly acidic in nature. Example, when alcohol react with ROH, react with metal sodium. That means we know that when acid react with metal, what will form? Salt plus hydrogen. Similarly, when alcohol react with sodium metal, what will get? We get RON, sodium salt of this alcohol. That means we get RON plus H. That means in a balanced state we can write it as a half H2. So look at here. Here you can see that alcohol is acting as an acid, because the normal or a common reaction of acid is acid can react with the metals, and what will form? Salt plus hydrogen. Similarly, the same way alcohol is reacting with the sodium metal, and what will form? Sodium salt of acid. That means sodium alkoxide. Sodium alkoxide plus what will be evolved? Hydrogen. Yes, is evolving. Okay. Particular example means if you take ethanol, CH3, CH2OH. Ethanol react with the sodium. What will form? We get CH3, CH2ON. CH3, CH2ON, sodium ethoxide. What is this one? Sodium ethoxide. Ethoxide plus what will be evolved? Half H2. That means here you can see that alcohol is acting as an acid, and keep it in mind, alcohol is very weakly acidic in nature. Another example, if you take CH3, CH3OH, this is a tertiary alcohol, no problem. It is reacting with another metal like aluminium. What you will get? We get aluminium salt of this alcohol. That means CH3, CH3. Here it is O. And here you can see that thrice Al. What is the reason? Because aluminium is trivalent. That is the reason you are getting this aluminium salt of this alcohol plus half H2. Okay, half H2. Okay. And look at here. I have told you that alcohol is weakly acidic in nature. Why alcohol is weakly acidic in nature? Or first we can discuss what is the reason for the acidity of alcohol. If you take ROH, you can see that this OH bond is a polar bond. That means this is partially negative, and hydrogen is partially positive. That means there is a chance of producing H plus ion. Thus, any species which can produce H plus ion can act as acid, or you can say that is acidic in nature. Here, because of the polarity of OH bond, you can see that this hydrogen is getting a partial positive charge. Of course, if hydrogen atom is removed, H plus is removed, it can act as acid. But it is that is the reason for why alcohol is acidic in nature, due to the polarity of OH bond. Due to the polarity of OH bond, there is a possibility of producing H plus ions or protons. That is the reason why alcohol can act as acid. Now, why alcohol is weakly acidic in nature? Weakly acidic in nature means a strong acid means the acid which, or a species which can immediately produce H plus ions. That type of acid we can call it as a strong acid. If the removal of H plus is not easier, if the removal of H plus is not easier, that type of acids are weakly acidic in nature, or that substance is weakly acidic in nature. If H plus is immediately removed, acid is strong, and if H plus is very difficult to remove, means that acid is weak in nature. Now, as I told you, alcohols are weakly acidic in nature. Weakly acidic in nature. Why alcohols are weakly acidic in nature? Look at here. If I take a particular example, CH3OH, CH3OH, and I told you this is delta minus and hydrogen is delta positive. This is the reason why alcohols are acidic in nature, due to the polarity of OH bond. Now I am explaining why they are weakly acidic in nature. You can see that this alkyl group, we know that alkyl groups are electron pushing effect or electron pushing group. That means this is plus I effect, plus I effect. Alkyl groups can push electron towards oxygen or towards OH group. Therefore, what will happen? The electron density around this oxygen will increase. That means when the electron density around the oxygen atom is increasing, what will happen? This oxygen atom or this negatively charged oxygen will attract back the H plus ions. Therefore, the removal of H plus will become difficult. Once again, we know that alcohols, if I take another alcohol, secondary alcohol, CH3CH, OH, CH3CH, OH, CH, this is a secondary alcohol. And first you must know that alcohols are feebly acidic in nature due to the polarity of OH bond. That means oxygen is delta negative and hydrogen is slightly delta positive. That means there is a possibility of producing H plus ions. That is the reason why alcohols can act as acid. Now, at the same time, alcohols are weakly acidic in nature. Alcohols are not strong acids. They will not show other reactions of other properties of a strong acid. Of course, it can react with only with metals, but they cannot react with alkalis or metal carbonates. That means they are very, very weak in nature. Now look at here, why they are very weak in nature. We know that alcohol, this alkyl groups have electron pushing effect. That means plus I effect. Because of the electron pushing effect, plus I effect, the electron density around oxygen atom, this electron density will increase. When this electron density around this oxygen atom, what will happen? When negative charge on the oxygen atom is increasing, what will happen? The force of attraction between negatively charged oxygen and positively charged hydrogen will become stronger, and hence the removal of H plus become difficult. That means it will become a weak acid. Now, in the case of secondary alcohol, look at here. There are two alkyl groups. That means here it is plus I effect, and plus I effect. Ultimately, what will happen? The electron density around this oxygen atom will be very high. That means again the removal of H plus ion become more difficult. It will become more difficult. Okay, and when you take a tertiary alcohol, you can see that CH3, OH, you can see that here it is plus A effect, and because of, you can see that the resultant negative charge on the oxygen atom will be very high, and therefore the removal of H plus ion become very difficult. That means the order of acidity of alcohol. What is the order of acidity of alcohol? Order of acidity of alcohol, you can write it as primary, then secondary, then tertiary. Okay, this is the order of acidity of alcohol. That means when you compare the acidity of primary, secondary and tertiary, you can see that the acidity is more in the case of primary, then secondary, and tertiary alcohol is least acidic, because in tertiary alcohol there are 3 alkyl groups, and because of these 3 alkyl groups, the plus I effect will be maximum, and hence the negative charge on the oxygen atom will be maximum. Therefore, the removal of H plus will become difficult. This is the reason why alcohols are weakly acidic in nature. And one more point you have to remember. Alcohols are less acidic even than that of water. When you compare the acidity of alcohol and water, we can see that water is more acidic than alcohol. Then, example, you can see that when alcohol reacts with water, ROH plus H2O, ROH plus H2O, what will happen? You can see that here water is acting as acid and water is acting as acid. That means H2O, water will donate H plus ion, H plus and OH minus is here. That means this lone pair will attract this H plus ion. That means alcohol is changing to ROH, H with a positive charge, and what will be produced? OH minus. Here you can see that acid, water is acting as acid. What do you mean by acid? The species which can donate H plus ion. Here in this reaction, acid is donating H plus ion, water is donating H plus ion, and that H plus ion is taken by alcohol. Therefore, alcohol is acting as a base in this reaction. That means when you compare the acidity of alcohol and acid, water, we can see that water is more acidic than alcohol. That means when you mix alcohol and water, you can see that H plus is transferred from, proton is migrated from water to alcohol, That means water is acting as acid and alcohol is acting as a base, because alcohol is accepting H plus, acid is, water is donating H plus. Therefore, water is acid and alcohol is acting as a base. And here you are getting, this is conjugate acid, conjugate acid, and this is conjugate base. Okay. So keep it in mind, alcohols are less acidic than water. Now, second example. So what we are discussing the reactions of alcohol. Now, number one, first one, reactions involving the cleavage of OH bond. Out of that, the first example is acidity of alcohol. Acidity of alcohol means there is a cleavage of OH bond and H plus is removed. Then second example coming under this one, esterification reaction. Esterification reaction. As you know very well, what do you mean by esterification reaction? Carboxylic acid react with alcohol in the presence of concentrated H2SO4. Concentrated H2SO4 will give ester. That means, what is the general equation? Carboxylic acid RCOH react with alcohol R dot OH. Okay, keep it in mind how I am writing alcohol. Okay, so R dot OH. Okay, you can see that H plus from alcohol and OH from acid, and what you will get? You will get R C double bond O, R C, CO means C double bond O R dash. Okay, so this is what is called ester. So here also you can see that OH bond, the OH bond in alcohol is breaking. Here this bond is breaking. So ROH, this is our R dot OH, this is our alcohol. Here also you can see that the OH bond is breaking, and this H is joining. Here it is OH, H2O is removed, then remaining RCOO R dot, RCOO R dash. Okay, that is what is ester. So so this reaction is very familiar to you. Esterification reaction. What is esterification reaction? The reaction of carboxylic acid with alcohol in the presence of concentrated H2SO4, and we get ester. And in this reaction also you can see that the OH bond is breaking. OH bond is breaking from OH bond in the alcohol is breaking, and we get ester. Now you must remember another esterification reaction. Its name is a Fischer esterification reaction. Fischer esterification. Fischer esterification. Or another name is Fischer Spear esterification. Okay. Or simply Fischer esterification, or you can call it as a Fischer Spear esterification. In this esterification reaction, an ester is produced by passing dry HCl gas through a 1:1 mixture of carboxylic acid and alcohol. What is Fischer esterification reaction? Esters are prepared by, esters are produced by passing dry HCl gas through a 1:1 mixture of carboxylic acid and alcohol. Carboxylic acid and alcohol. That means the equation and everything is same only. RCOOH, carboxylic acid, react with the alcohol, ROH or R dot OH, in the presence of dry HCl. Okay, here the reagent is like our dehydrating agent, because ultimately what is happening? H2O is removed. Here you are using dry HCl. You are getting RCOOR plus H2O. If you are using dry HCl, the reaction is known as a Fischer esterification or Fischer Spear esterification reaction. This type of esterification reaction we will get a very good yield of ester. Ester. Okay. If you try a specific example, CH3CH2OH, CH3CH2COH, propanoic acid react with CH3CH2OH, ethanol. What you will get? H2O is removed, and we are getting what is the ester? CH3CH2CO, CH3CH2CO, CH2CH3. Okay, this ester we are getting. Okay, what is the name of the ester? What is that? 2 carbon. This ethyl 1, 2, 3 propanoate. Ethyl propanoate. Okay, CH3CH2 ethyl. Then 1, 2, 3 3 carbon ethyl propanoate. Okay, this type of method of preparation of ester is known as Fischer esterification reaction or Fischer Spear esterification reaction. Esters are produced by the reaction of acid and alcohol in the ratio 1:1 by passing dry HCl gas is known as a Fischer esterification reaction. And keep it in mind the order of reactivity towards esterification. The order of reactivity of alcohols and acid towards esterification. We know that bulkier the acid or bulkier the alcohol, the rate of reaction will be lowered. That means we know that CH3OH. If you take this alcohol, methanol, for esterification, the reaction will be very fast. Then when you compare with ethanol, CH3CH2OH, or will be when you take secondary alcohol CH3OH, and the least reactive is CH3OH, oil. This is tertiary alcohol. What is the reason? We know that the steric factor is increasing. The steric factor is increasing. Therefore, its ability to react with the acid will decrease. That means this is the order of reactivity of alcohols towards esterification reaction. And if you take acid, same way, the most reactive acid will be formic acid, HCOH, correct? This will be most reactive. Then what is that acetic acid, CH3COH. Then what will be that propanoic CH3, CH2, COH. Then what will happen? CH3, CH, CH3, COH. Okay, this way it will go. That means here also the steric factor is important. We can see that formic acid least sterically hindered acid, therefore it can immediately undergo esterification reaction. So keep it in mind, bulkier the alcohol or acid, the rate of reaction will be slower. Okay, this is the first type of reaction we have explained. That means the reactions involving the cleavage of OH bond, involving the cleavage of OH bond. First one, reaction with metal. Reaction with metal, the OH bond is breaking and H2O gas is evolved. In that heading only we are explained the acidity of alcohol. And the second example is esterification reaction. These are the two examples you have to study under the heading reactions involving the cleavage of OH bond. Okay, thank you.